Greetings and a warm welcome to all the fantastic people joining us today. We are grateful and honored by such a positive response to our initiative. Never more than during these challenging times, it is important to stay connected, to not slow down the dialogue between the professionals in this industry, the dialogue that is fundamental to bringing progress and technology advancement from our books and roundtables to the people. With that goal in mind, we decided to reach out to the world through a series of online events like this one, to keep the communication going and to make the information available to the many. We hope that you will find this webinar interesting and informative, and that we will see many of you joining us also at the upcoming events of Primozone webinar series. Today's presentation will be about ozone and its benefits and will take approximately 45 to 50 minutes. It's supposed to be suitable for both those of you who have never worked in the ozone before and you who have a long experience with it. If you have a question specific to you, your company or application, please send an email to info@primozone.com. For those of you who would like to take a second look at the content, and for those you know who couldn't make it today, a link to a video recording of this presentation will be sent out to the email address that you used to register. Now, let's start. Today's agenda will start with a short introduction of Primozone for those of you who haven't worked with us before, but also to share the latest updates about our company and product portfolio. The next section describes what ozone is and those of its characters that are relevant to water treatment and other ozone applications. Following, there will be 3 sections about the many benefits that ozone can provide, 1 section about the benefits that ozone has on different treatment processes, ranging from disinfection to specific industrial applications. 1 section about practical benefits, the advantages that an ozone system has compared to systems using other treatment methods. And finally, in section 4, we'll walk you through the benefits of choosing ozone can bring to our precious and endangered environment. Some of the sections will reference to real-life cases of Primozone installations in which these benefits are most evident. This is me, Jesper Kedström, doing the first part, and the following part will be Ilaria Azzarà. We'll start with a short introduction of Primozone. Since Primozone's foundation more than 20 years ago, Primozone has been based in Löddeköping in the south of Sweden. All Primozone products and everything inside them are made in Sweden. Each individual component is manufactured nearby, and also the know-how comes from here, as our R&D, production and final testing are in-house. We are also very proud to have a strong, well-established, long-sighted owner, the Norwegian family-owned Westphalasen Group. With over 100 years of history, they have been our only owner since 2003. Our vision has always been to bring powerful, cost-efficient, robust, compact, yet elegant ozone generators to the market. And our goal is to redefine ozone technology worldwide. Talking about worldwide. Worldwide is a key word for us. We have always been working towards the international market, and now we're a little bit more international with our newly founded subsidiary Primozone Inc, located in Melbourne, Florida. Our aim for Primozone Inc is to be a reference point for sales and technology support, not only in the US, but the whole of North America. Since the first Primozone installation in Ljungskile back in 2006, Primozone has expanded globally, and already our second installation was outside Sweden, namely Åland in the Baltic Sea in between Sweden and Finland. We can now proudly state that the number of Primozone installations worldwide exceeds 500. During the years of our growth, we have always kept an eye on the evolving regulations, leading us to other very important steps in our development, approvals and certifications. In addition to the CE marking on our entire product series, we now offer CUL approved control panels to the United States and Canada. We pursue high quality and efficiency, not only of our products, but also on our company, which is certified compliance to ISO 9001 for quality management and ISO 14001 for environmental management. Primozone also owns a letter of access for the Ozone group dossier of approval of ozone as a safe biocide according to the European Union Biocidal Directive. Primozone operates in three main sectors: aquaculture, industrial, and municipal. Aquaculture, more specifically recirculating aquaculture systems. Scandinavia is leading the world of aquaculture and the progress in sustainable fish farming. We are proud to be part of this as the #1 provider of ozone solutions for aquaculture in the world. We are in a number of industrial sectors and have experience with the applications of ozone to many different processes. Thanks also to our product, which reliability and performance can meet even the highest demands. For example, those of the photovoltaic and semiconductor industry. In the municipal sector, we work with both drinking water and wastewater applications and have systems for water reuse and sludge control. One of our core products is, of course, the Primozone ozone generator. The GM124 2.0 on the picture is our newest series of ozone generator, the most compact machine which can generate up to 240 grams of ozone per hour in the space of a bit more than half a meter in cube. They are not only space efficient, but they also save energy in time with the newly introduced features, which allows user of warmer cooling water, increasing generator reliability even more, and make it quick and easy to use with a modern and user-friendly interface. Modularity and scalability have always been key to Primozone features. And so our ozone generators line ranges from the GM124 to single-sided generators GM6, 12 and 18, to the double-sided generators GM24, 36, 48, from 6 up to 2,400 grams of ozone per hour. This is done while keeping the same core, the Primozone patented reactor and power supply, and the same benefits: small footprint, high reliability, and minimal maintenance needed. In addition to the ozone generators, Primozone offers a series of supporting products to build an ozone system with overall efficiency and reliability. Some of those are shown here. You have the Primozone backflow protector to keep your equipment safe from problems arising during downstream in the process. Probably the cheapest investment you can do to save your ozone generator from backflow of water. We have the latest arrival in the series, the Primozone CSM cooling skid for effective cooling with minimal energy consumption where cooling water is available. And then we have the Primozone LOX booster to minimize the loss of ozone production and maximize your equipment performance when producing ozone from liquid oxygen. Now I'll hand over the microphone to my colleague Ilaria Azzarà, and she will tell you all about what is ozone.
Thank you, Jesper. And hello, everyone. So now from Primozone to ozone. All ozone providers owe their success to this powerful molecule and its unique, extraordinary features, which we will now look into. Ozone is a similar molecule to oxygen, more specifically an allotrope of oxygen, one of the different physical forms in which the element can exist. At room temperature, both ozone and oxygen are gases, but while oxygen is odorless and colorless, ozone is characterized by a pale blue color and a unique strong odor, which gave it its name. The word ozone comes from the Greek word ozine, which means in fact to smell. Molecules form when the total energy of the electrons is lower in the molecule than in the individual atoms. The lower the energy, the more stable the molecule. The oxygen molecule, O2, is the lowest and therefore most stable energy state and most common oxygen allotrope in nature. There is a very strong double bond between the two oxygen atoms, which we need energy to break, electricity in normal practice. A small part of the electricity that we apply to oxygen will be transferred to its atoms, bringing them to a higher energy state, individual oxygen atoms, also known as oxygen radicals. Oxygen radicals are characterized by very high energy. They are very unstable and will tend to bond with whatever can bring them to a lower energy state. When a single oxygen atom creates a bond with O2, ozone will be formed, O3. Ozone's energy level is in between those of the oxygen radical, the highest, and of the oxygen molecule, the lowest. The bond between the oxygen molecule and the third oxygen atom is a single bond, which is weaker and less stable than the double bond between the oxygen atoms forming O2. Ozone is still a very high energy molecule, which means it is less stable than oxygen. Ozone won't stay ozone for a long time. It will always tend to revert to oxygen, its lower energy state. It will do so either through a chemical reaction with a different compound or spontaneously over time. The half-life in water at room temperature is only 20 minutes, which means that over this time, half of the ozone will have decomposed back to oxygen. At higher temperatures, the half-life will be shorter. In other words, in warmer water, ozone decays faster. This is not only true in water, heat in general destroys ozone, which is a critical aspect in the design of ozone generators, ozone distribution systems, and ozone processes. Temperature can play an important role in the design of ozone systems, especially for application to warmer effluents, like, for example, industrial wastewater. Temperature is also important when the reaction with the target compound itself generates a high amount of heat, which could affect the next steps in the process. When ozone reacts with certain compounds, heat is generated, and if these compounds are present in high quantities and the effluent is being recirculated for complete treatment, its higher temperature can make the application of ozone less and less effective over time. Next slide, please. Thank you. Ozone and oxygen are both essential for our survival. For example, the ozone in the atmosphere shields us from the sun's harmful UV light. But ozone, unlike oxygen, is not a gas that we should breathe. It would have a harmful effect on our lungs. This led to the common misconception of ozone being a very dangerous chemical, while in reality, ozone is not any less safe than other common substances used in the industry. One clarifying example is perhaps nitrogen. It is used in food packaging, like packed meat and vegetables, to preserve their freshness, protect their nutrients, and prevent microbial growth. Nitrogen cannot be detected by humans, and the nitrogen-enriched environment depletes oxygen. So, if the concentration of nitrogen is too high, the body becomes oxygen deprived before one can even realize what is happening. That is definitely not the case with ozone, which has such a strong smell that people can detect its presence at a concentration in ambient air, which is much, much lower than what would be dangerous. But let's look together at some ozone facts, which will hopefully make us more familiar with this substance. Ozone is naturally occurring. It is produced, for example, by lightning and by UV light from the sun. A small percentage of the Earth's atmosphere is ozone, and ozone is also part of the stratosphere. Ozone is approved as a safe biocide according to the Biocidal Products Regulation. An active substance must be evaluated and approved before what produces it can be made available on the market or used in the European Union. FDA rules establish that ozone is generally recognized as safe, and that means it can be used on food products. The safe exposure limit, what man can safely breathe for 8 hours, is a time-weighted average of 0.1 ppm. Ozone has been used for over a century to treat drinking water, and ozone is dangerous to life or health at 5 parts per million, but most humans can clearly detect ozone already at 0.02 ppm, which is 25 times lower. And finally, the number of people on hospital records that have died from ozone gas is 0. Now that we have brushed up our knowledge of ozone, let's go straight to the benefits. Coming next, the benefit of ozone on treatment processes. Because of its high energy, ozone is extremely powerful. Its oxidation potential, also known as redox potential or ORP, is a measure of the tendency of ozone to acquire electrons, to be reduced, or a measure of its tendency to oxidize, if we see it the other way around from the target compound perspective. Redox potential is measured in volts. The higher its value, the greater the species' affinity for electrons and tendency to oxidize. As we can see in this list of oxidizing reagents, ozone has the highest oxidation potential after fluorine. The use of fluorine for water treatment is, however, not practical. Therefore, ozone can be considered the most powerful oxidizer available for water treatment applications. One more thing that we can notice in the list, ozone has a 50% higher oxidation potential than chlorine gas, and more than double compared to sodium hypochlorite, which oxidation potential is often used as a reference. Another characteristic which makes ozone perfect to attack microorganisms and dissolve pollutants is its high solubility in water. Pure ozone is 13 times more soluble than oxygen, but in practice, ozone is not used pure. It is generated and applied as a gas mixture, ozone mixed in oxygen. Two parameters influencing the solubility of ozone gas in water are pressure and temperature. Higher pressure and lower temperature will lead to increased gas solubility. Lower pressure and higher temperature will lower the gas solubility. A third parameter is the percentage of ozone in the gas mixture, the ozone concentration. It can be lower or higher depending on the specific ozone generation technology that is used. But the higher the ozone concentration, the higher the solubility in water of the gas mixture. This is very important to remember when looking up values for ozone solubility. The values might be expressed at a different concentration from what will be used in a specific project. And if a project involves the addition of high quantities of ozone to an effluent, working at a higher ozone concentration can help by maximizing the solubility in water of the ozone gas. Disinfection. It is defined as a process designed specifically to destroy pathogenic organisms. It kills bacteria, protozoa, cysts, and viruses. Commonly applied disinfectants, such as chlorine, penetrate the cells by diffusion. Within the cell, chlorine affects the microorganism enzymes. UV light inactivates microorganisms by destroying parts of their DNA, leaving them unable to perform vital functions. Ozone works on a completely different principle. Because of its high oxidation potential, ozone oxidizes the bacterial cell wall. Once ozone has entered the cell, it oxidizes all essential components, enzymes, proteins, DNA, RNA. The cellular membrane is damaged by ozone, so the cell will fall apart, and the damage is permanent. What does this mean in practice? While microorganisms can become resistant to biocides like chlorine over time, they can never become resistant to ozone. Some can reactivate after inactivation with UV light. There is no such thing as reactivation of pathogens after ozonation. Ozone will be always effective. Its disinfection efficiency is independent from pH and temperature variations. Ozone can provide any level of disinfection with any quality of water and wastewater, while UV, for example, needs good transmittance to be effective. Chlorine, although suitable for the activation of bacteria and viruses, cannot be effectively used to deactivate protozoa, while ozone can. Activated carbon absorption is not an effective method for removal of, for example, 1,4-dioxane, because this contaminant is hydrophilic, which means it has a very high affinity for water, and so it is completely soluble. Ozone can destroy contaminants even if they are completely dissolved in water. Ozone's broad effectiveness is a great benefit today, but it will be an even greater one tomorrow. Ozone is the only disinfectant which also breaks down contaminants of emerging concern. So installing an ozone disinfection system today will comply to the strict upcoming rules for removal of these contaminants. A different system will have to be replaced to comply with the same rules. Being a highly reactive oxidant, ozone has many different applications. If we just look at the so many things that ozone can do in a drinking water treatment plant, it can be used for disinfection or applied earlier in the process to reduce disinfection byproducts. It can deal with taste and odor issues, not only in surface water but also in groundwater, breaking down odor-generating compounds like hydrogen sulfide. Applied as a preoxidant, it can remove iron and manganese, and so on. There are also many possibilities to apply ozone in a wastewater treatment plant. Again, disinfection, but also color removal, odor control, COD reduction, removal of pharmaceutical residues prior to discharge to prevent the contamination of the receiving surface waters with pollutants that might affect marine life or make their way to the intake of a drinking water plant. There are ozone applications also for sludge conditioning and in the fast-growing sector of water reuse. The range of industrial applications of ozone is even wider. We have, for example, treatment of ballast water to prevent contamination of the marine environment where the ballast water is discharged with different species or contaminants loaded up elsewhere. We have cooling tower applications and applications in the oil and gas sector. Ozonated water can be used for bottle rinsing and filling, or on crops and fruits to extend their shelf life and protect them from parasites. Ozone can be used to bleach pulp and textile, but also to remove color from the wastewater of paper mills and textile factories. With these and many more applications, ozone proves itself extremely versatile, bringing benefits to a number of sectors. The benefits of ozone in the aquaculture sector are outstanding. Ozone is often used in recirculating aquaculture systems to keep the water clean and to limit the amount of makeup water needed for the fish farm operation. Using ozone for this purpose also leads to an increase in the dissolved oxygen content of the water and to a general water quality improvement, which has a positive effect on the fish health and growth. Consequentially, the productivity of the fish farm increases, not only in number, but also in each fish slaughter weight. Ozone is also used to disinfect the intake water of fish farms to prevent the spread of diseases, which could make the farm lose an entire batch of production. The positive effects of ozone can be detected even in the final product, as ozone can remove from the recirculating water compounds which might give a characteristic off flavor to the meat of farmed fish. Ozone can bring benefits to industrial processes which one would not expect. Here we would like to share with you some of the most promising and most interesting effects of ozone in different industrial sectors. First one is surface activation. Ozone can make surfaces which would normally repel each other stick together. This is beneficial for the food packaging industry in the process step where different layers of multi-layered food packaging are glued together. Ozone will make these layers stick together quicker and increase the productivity of the food packaging production plant. We have an example of that in our closest vicinity in the city of Lund. In the process of production of solar wafers, there is a cleaning step in which heavily ozonated water can be used to get rid of chemical residuals. This step increases the efficiency of the solar wafers. Primozone has over 100 installations for this application, but it is to be noted that due to the very high dissolved ozone concentrations involved, the ozone must be produced at the highest concentrations for this to be feasible. Ozone can be used not only in water, but also in air. If ozone is injected in the exhaust of, for example, a restaurant, it can break down grease and prevent its accumulation in the exhaust ducts. This will avoid that the energy required for ventilation increases over time because of the grease buildup. And mostly important, it will eliminate a fire hazard. We have then textile bleaching. Everybody knows the effect that bleach has on clothing. What you might not know is that also ozone can obtain the stone wash effect on jeans. This can be done by special industrial washing machines made to obtain this nice design without the use of polluting chemicals. Primozone is proudly part of many of these environmentally friendly systems for jeans bleaching installed worldwide. Filamentous bulking sludge is a well-known problem at wastewater treatment plants. Filamentous bacteria grow on the sludge surface and prevent its settling. Normally, ozone wouldn't be considered a suitable solution as it is a very powerful, non-selective oxidant. So the concern would be that ozone kills all microorganisms in the sludge, including the good bacteria. Surprisingly, ozone has been proven to selectively break down the filamentous bacteria first. So a small seasonal ozone dosage can improve settling of the sludge without affecting its quality. And finally, reduction of surface tension. Ozone can reduce the energy required to pump water deep underground, a benefit, for example, in oil and gas applications. From all the great things, well-known and unexpected, that the small ozone molecule can do, let's dive into the practical advantages of ozone systems, and I'll hand over here to my colleague Jesper.
Thank you very much, Ilaria. As ozone is an unstable form of oxygen, it can't be stored nor transported and must therefore be produced on site, where and when it's needed. For this reason, ozone generators have been developed. This might sound as a disadvantage at first, but it is thanks to the natural characteristic of ozone that there has been a great technology advancement in ozone generation technology. As we must produce exactly the quantity of ozone that is needed, ozone generators have been developed in many different sizes to adapt to each single user's demand. Also, as we must produce ozone exactly when it's needed, and ozone demand is rarely constant, the evolution of ozone generator technology brought to the market is not only scalable, but also faster machines which can start up, ramp up, and react to changes in the ozone demand much quicker than in the past. There is an increasing level of automation in the ozone equipment and systems, making operations almost fully automatic and limiting the amount of human interaction needed on a daily basis. Today, the use of ozone is just as simple as the use of regular chemicals, but with ozone, there is no need to ship or handle chemicals products, which relates safety hazards and hassles. There's also no need to store dangerous chemicals, which is also a safety hazard and a loss of available space. Ozone is a very powerful disinfectant. It is more powerful and faster acting than chlorine, chloramines, and even chlorine dioxide. The result in lower CT values for inactivation of pathogens, as we can see in this table from the EPA. See the large difference between even the free chlorine compared to the ozone makes it really a tough product. The CT value is the product of concentration and contact time. Contact tanks are designed to provide a certain contact time for a certain flow. So their dimension at a constant flow depends on the required contact time. The CT value, that's the contact time, and therefore the size of the contact will always be lower with ozone. With shorter necessary contact time, the transition is sometimes possible from a traditional concrete basin to a serpentine ozone contactor. This is a simpler, more space efficient and cost efficient method to achieve contact time, which we can see one example of here to the right. Doing more than one thing at a time and doing them well is everything but easy, I can tell. But ozone, unlike us, is great at multitasking. The most common reason for using ozone at the first step of the drinking water treatment process is to reduce disinfection byproducts. But the application of ozone to raw water will bring several positive side effects. It will improve taste and odor of the water. It will improve it will provide a barrier against contaminants entering the plants, such as, for example, pesticides. It will turn iron and manganese from solubles to suspended, making them easier to filter. It will also extend the filter lifetime, including GACs, granulated active carbon, and increase the time between backwashes. Furthermore, partial oxidation with ozone will polarize the target compounds, so increase the efficiency and effectiveness of the flocculation, coagulants, or polymers in the steps. In other words, pre-ozonation, a lower amount of chemicals will be needed. And what about wastewater then? Well, the most common application is disinfection, but ozone can do so much more in the wastewater treatment process. If applied in the intake, ozone can break down complex organisms to make them more biodegradable, bioavailable, and improve the removal of biofilters. Ozone will also increase the biodegradability of wastewater and reduce the organic load on disinfection, thus reducing the required amount of disinfectant concentration. If applied later in the process, ozone can be used not only as a disinfectant, but also to oxidize color and to get rid of the contaminants which are harder to remove. It will also increase the dissolved oxygen content of the wastewater, which will improve the oxygen content of the receiving body of water. And the best thing is, ozone can achieve several water treatment goals at the same time. It has multiple benefits when applied at a single point in the process, but a single ozone system can produce ozone and distribute it to different steps of the treatment process, or even of the wastewater treatment plant. For example, if used for disinfection and for sludge conditioning. The capital cost of ozone equipment is generally higher than the cost of other treatment methods. However, it should be kept in mind that it also keeps operating costs down. The following facts are to be considered when evaluating the capital expenses against the operation cost of an ozone solution. As we just saw, ozonation will achieve several water treatment goals at the same time. One ozone system, that is one capital expense, can bring benefits to multiple parts of the treatment plant. Ozone also reduces the operating cost of other water treatment steps, for example, reducing the amount of chemicals needed for coagulants and flocculation, extending the lifetime and and the time between backwashes of filters. Pre-ozonation can reduce the amount and the cost of disinfectant needed. Also for residual, because if the water has been ozonated, the residual in the finished water can last longer in the distribution network. Compared to ozone, other treatment methods needs continuous sourcing and transportation of chemicals, a high and constant expense. Some methods need regular replacement of parts and regular maintenance, for example UV. Some methods generate waste which disposal can be difficult of and expensive, like contaminated activated carbon. Primozone ozone generators need minimal preventive maintenance and no regular replacement of parts or disposal of any material. Having that in mind, this is the last section for today, but not at all the least important. It's about the benefits of ozone for the environment. For more than 20 years, Primozone has worked to make ozone widely available and easy to use, with the ultimate goal to spread throughout the globe what we consider to be the natural way to clean water. Ilaria, please go ahead.
Thank you, Jesper. Ozone can lead us away from micropollutants. Micropollutants are contaminants that, because of human activities, are found in water at concentrations well above their natural level, even though they still remain at trace levels. The list becomes longer every year, and it includes, for example, pharmaceuticals, artificial sweeteners, hormones, and caffeine. Ozone effectively breaks down micropollutants. Primozone has taken part in an extensive study which looked specifically at pharmaceuticals. A study started because of the devastating effects that the discharge of pharmaceuticals has had on surface water and aquatic life in Sweden. The study has shown that 98% removal of most pharmaceuticals is achievable with ozone to target compound ratios ranging from 3:1 for the most common painkillers up to 9:1 to break down proteins and the most complex molecules. Being able to remove pharmaceutical residues is of critical importance not only for the environment, but also for wastewater treatment plants because of the upcoming regulations. In Switzerland, it is already by law that all new wastewater treatment plants must be able to achieve 80% removal of incoming pharmaceuticals, and similar rules will be soon implemented in the entire European Union. Micropollutants generally survive traditional treatment. They make it through the treatment plant and can end up being discharged in the environment. In most cases, ozone will succeed where traditional treatment fails. And when even ozone alone cannot oxidize the target compound rapidly, an ozone-based advanced oxidation process can be the solution to achieve fast and effective removal. An ozone peroxide AOP, for example, can achieve almost complete reduction of most contaminants. One of the most interesting and most promising applications of ozone is water reuse, a sector which is growing extraordinarily fast in a world where water becomes more and more scarce every day. Intensive research and development of more advanced treatment processes is the only way to reclaim at least part of our most precious resource and get away from water waste. Due to the high level of treatment needed for reuse, ozone is generally combined with other treatment technologies for reuse applications, for example with UV. This makes it possible to recover irrigation water, storm water, or even wastewater for uses ranging from landscaping to the irrigation of crops, all the way to potable water. One example that shines in this sector is Los Angeles County Gates Canyon Park, where storm water is reused for irrigation of the park, thanks to an advanced treatment process based on ozone and UV. Ozone doesn't leave any undesired traces behind. All we need to generate ozone are oxygen and electricity. And ozone generators, as we said, do not have parts that need to be replaced regularly and do not generate waste. making it a technology with minimal environmental footprint. Also, due to its instability, ozone's lifespan in aqueous solutions is very short, less than an hour, so any ozone residuals will not persist. Ozone is nothing more than a higher energy state of oxygen, so whether it does or it doesn't react, it rapidly decomposes in water, reverting back to oxygen. As a consequence, removal of the residuals is not necessary, unlike, for example, with chloramines, which can persist for a long time. When chloramines are chemically removed, ammonia may be released, which has a toxic effect on fish, causes corrosion of lead and copper, and serves as a nutrient for nitrifying bacteria, so it can cause nitrate levels to rise. All that is left after some time from applying ozone is oxygen. So on the opposite, the increased oxygen levels consequential to the use of ozone have a positive effect on marine life, a great benefit for the receiver waters of a wastewater treatment facility, and a great benefit also in recirculating aquaculture systems. Here we can see a little bit better the different steps of ozone generation and reaction. Start from oxygen. We apply electricity to break it into atoms, only 2 ingredients, as we said. The single atomic oxygen bonds with an oxygen molecule and forms O3. When ozone reacts, or after time, the third oxygen atom is released, and we're back at the beginning of the cycle, to oxygen. Disinfection byproducts, or DBPs, are mainly formed during the reaction between organic material and a disinfectant. The reaction of chlorine with organic matter can lead to the formation of chlorinated disinfection byproducts, such as trihalomethanes, THMs, which are classified as carcinogenic to humans. Using ozone, we can get away from the risk of forming dangerous byproducts. Ozone's DBP formation potential is minimal, and because ozone can remove DBP precursors. For example, at Canyon Regional Water Lake Dunlap Water Treatment Plant in Texas, ozone is used as a pre-oxidant to reduce THM formation, at the same time as dealing with cryptosporidium and seasonal taste and odor issues caused by algae blooms. One of the best benefits of ozone is that there is no common disinfection byproduct of ozone, just oxygen. Speaking of disinfection byproducts, the question might arise, what about bromate then? Bromate formation can occur when elevated concentrations of bromine are present in the raw water, more than 50 micrograms per liter, that is. But bromate formation can be mitigated or even prevented with simple process changes. The simplest but not the only methods to avoid bromate formation are: number 1, utilizing ozone at higher concentrations by weight. This will have many side benefits, such as reduced oxygen consumptions, improved mass transfer, smaller contactor size, and lower side stream injection pumps horsepower. Number 2, injecting ammonia right upstream the ozone injection point in the contact chamber. So, with just some attention during the process design, ozone can lead us away from the old issue of disinfection byproducts. At Primozone, we consider ozone a way to a sustainable future. If polluting chemicals are used to achieve removal of a target contaminant, the cure could be worse than the disease. That is not the case with ozone. By reducing the use of chemicals, ozone can be the key to more sustainable and environmentally friendly water treatment and industrial processes. When ozone is used for disinfection, it can limit the use of chlorine to the amount needed for residual. And ozone can replace chemicals in industrial applications, like textile and pulp bleaching, or in cooling towers, like the ones of Hechi power plant in China, the installation that we're showing here. Ozone helps making agriculture more sustainable, allowing reuse of water for irrigation. For example, at Metrolina greenhouses in Charlotte, North Carolina, water reuse would not be possible without ozone, used to break down a growth inhibitor that is used on certain plants but shouldn't end up on other plants. Ozone makes energy production more sustainable by lowering the amount of makeup water necessary for the operation of cooling towers and by being part of cleaning processes that increase the efficiency of solar cells. And finally, ozone makes aquaculture more sustainable by improving the fish health and growth rate in recirculating aquaculture systems. Ozone supports the transition of fish farming from open waters to land, and so the conservation of our beautiful coast and surface waters. Ozone is part of sustainable fish farms like Valperca in Switzerland, shown in the picture here. And with this look forward to a bright future with a cleaner world, we would like to conclude our walk through the numerous benefits of ozone.
Thank you very much for joining us today and for your attention at our presentation. If you have any questions, please don't hesitate contacting us. We'll be happy to help and clarify any doubts. We're also very grateful for any feedback about the webinar, as it is the most valuable input for continuous improvement of our events. And don't forget to send any emails to info@primozone.com for attention from us. Finally, thank you very much, Ilaria.
Thank you very much.
And thank you all for listening.